after you finish your installation, you need to change the power rights. Power rights give the full control to the direction library here. Library give the full access. Totally control. Totally control. 这是完全控制 ，totally control。totally control。full access to the directory. We use 80 line C51 here add this firewall. Firewall 8041. We use assembly language. Just use the default setting. Default setting. ASEM51. Protos has complaint for assembly language. If you want to C language, you need to change the change to for Care4 85. Care4 85. 8051. Here is for assembly language. Here is for C language. C language. Yeah. Is this is an empty program. So if you want to change your code. Just write your code here. Just write your code here. For example, if we want to study here. Which means because of the screen is small, so I install software and always on the top for the notepad, so I can edit the program. Yeah. C. So build, compile this, compare successful, so we can just run. If we run this program, we can see the register. Okay, you can have a rest. I check the something. What's the matter? Okay. This is a neutral loop. Neutral loop. We can see here. If you here, when you add your 8041, and double click and add this firmware. Here you can enter here is for your language. I just write the initial code here. Write your code here. Use the debug function. Use the start the debugging. We can see just here register. We can see the register in the microcontroller. Here is PC. Here is the current instruction. Here ACCB, DPTR. Or is register. Maybe we will use it. Here is a step over sort line. Is execute your language line by line. So we can hear. you see the hardware status in the 8041, you can check here. It is registered SFR memory, internal memory, and the source code. Here is internal memory. Here is FR code. It's registered. When we use this simulation, we can check here 8041 CPU register. So we can here, you can follow your instruction. We can show you how to check the status. Start the debugging. We restart the program. Restart. Here, move A, £00 is the first line. So or is 0, except SP is 7. So you can see if we continue to next language, step over source line. Yeah. The second language, move R2 £10. R2 here, R2 now is 0. If we go to the next instruction, R2 become A with 10 and 10. So we can execute the third language. Third language add £3. A is 0. Plus 3, which means A become 3. So you can check ACC is 3. So you can execute your assembly language line by line. So you can understand the status of the microcontroller. I think use this method is a good method for you to name microcontroller. Okay. Or example on the PPT, you can use it and exercise. So understand the function. So next, I just introduce the VT. If you anything you cannot understand, you can ask for. Yeah. Here is the loop. Here is the that is the loop, active loop. That means two level or three level loop. Three level loop. Jump. Jump is just according to the condition and jump to the level. JZ is according to the A, according to the A and the jump. JNC according to the stage of CY, to the CY and the jump. Here is 8041 conditional jump instruction. Conditional instruction jump. JZ according to A, JNZ according to A, DJNZ according to the register you used. CJNZ compare A and batch or some value or some register. JC according to CY, according to CY. Yeah, you can understand this jump instruction. All conditional jumps are short jump. The address of a target must within minus 128 and 2 plus positive 127 of the count of the PC. If we use 8 bytes, the maximum is FF. It means FF. But this sun number. This is 8 bits. But there is 1 bit we use for the sun, so only 7 bits. 7 bits. 7 bits for the short jump. The unconditional jump is a jump in which control is transferred unconditionally to the target location. This is unconditional jump. If you want to jump, just jump. No judgment. LJMP, long jump. SJMP is short jump. Long jump has 3 byte instruction. First byte is opcode is LJMP, long jump. Second and third byte is address. Is a 16-bit address. 16-bit address, which means from 0 to FFFH. Which means long jump. Can jump far away. Short jump has 2 byte instruction. First is opcode. S jump has itself. Second byte is relative target address. Forward positive 127 and backward minus 128. H or total 8 bit. Here is 6 bit. 6 bit. To calculate the target address of the short jump, the second byte is added to the PC of the instruction immediately below the jump. Short jump is a relative address, not a direct address. If the target address is more than minus 128 and 2 positive 127 bytes from the address below the short jump instruction, the assembler will generate an error stating the jump is out of range, which means you need to change to your code error jump, a long jump, not a short jump. And here is an example for jump. This is JZ. JZ and next. Next is here. The next JZ. The next is 03. Next is 03. Just add the 03 to here. 6 add 03. We can get 9. Get 9 is here. So just from here jump to here. From here jump to here. JNC. Is here is D. Next instruction is D. Here is 05. 05 has an addition. Just get 12. So here is jump from here to here. Yeah, from here to here. Next, introduce the core instruction. Core instruction is used to call subroutine. You know subroutine. Subroutines are often used to perform tasks that need to be performed frequently. A subroutine means some function. This makes a program more shortcut, more structured. In addition to saving memory space, if you have a subroutine, you need use it for many times. So you just make a subroutine and call the subroutine for 10 times. Here is the core L core, long core, and A core. Long core has 3 bytes instruction. First is opcode, the instruction L core itself. Second and third bytes are used for the address of touched subroutine. 64 key. A core 2 byte instruction. 11 bits are used for address. 11 bits are used for address. 2 key. Which means 11 bits. when a subroutine is called, control is transferred to the subroutine. The processor will do something. This processor saves on the stack the address of the instruction immediately below the error code. The first one, save. First save. Second, begin to fetch instruction from the new location. Do the two things. After finishing execution of the subroutine, the instruction RET instruction transfer control back to the corner. Which means return to the begin. Return to the begin. Every subroutine needs RET as the last instruction, which means if you write a subroutine, you need to end your subroutine with RET. With your RET. Here is an example. This is a delay subroutine. RET is the end of the subroutine. RET is the routine. So here is the main program. Here, error code delay. Upon executing error code delay, the address of the instruction below it move A #0AAH is pushed into stack. And the 8041 start to execute its 300H. Delay is here. Delay address is 300H. As an example for the subroutine. This program is about the two things. Here, 1, 2, 1, 2. Is firstly save the stack of the address of the instruction below the error code. 2. Begin to fetch instruction from the location. Here is an example. If you are interested, you can access this program after I give you. Okay. If you write a big program, so you need to make your program structure. So you need to write your program like this. This is the main program. Main program just error code. Your subroutine. So your subroutine is subroutine 1, subroutine 2, subroutine 2, 3, subroutine. Just if you write your program like this, so someone else reading your program, so he can understand your program easily. Yeah. This allows you make each program into a separate module. Each module can be tested separately and then brought together with the main program. In large program, the module can be assigned to a different program. You can program your subroutine and test separately. The difference between A core and the L core is the target address for L core can be anywhere within the 64 key. The target address of A core is within 2K bits. L core is 64 key. A core is 2 key. The use of A core instead of L core can save a number of bytes of program ROM space. A core use 2 bytes. L core use 3 bytes. If your memory is small, so you must save your memory space. But now the memories become larger. So this is maybe you needn't consider it for save your memory. CPU executing an instruction take a certain number of clock cycle. These are referred as a machine cycle. The length of machine cycle depends on the frequency of crystal oscillator connected to the 8041. In original 8041, one machine cycle lasts 12 oscillator period. Here, I introduce how to calculate the delay of your program. Here, I use the delay. When you make your program, maybe you use the delay often. So you must know your delay how long you delay. Firstly, we need to know the oscillator periods, so we can get one machine cycle. One machine cycle lasts 12 oscillator period. So if your oscillator period is here, so you can get your machine cycle. This is your frequency, the machine cycle. So the time for the machine cycle is 1 divide frequency. We can get 1.085 µs. For 8041 system, find out how long it takes executing each instruction. Here, move. This instruction use 1 machine cycle. Use one machine cycle. DEC for one machine cycle. DJNZ for two machine cycle. This is two machine cycle. DJNZ, LJMP, SJMP, LJMP. Also for two machine cycle. NOP is for one machine cycle. MAL AB for four machine cycle. Four machine cycle. So you can know how long the instruction spent.
How do you know the number of machine cycles?
You can check the instruction table. Yeah, the instruction table tell you how long.
Is there a limited number to the machine cycles?
Machine cycle what?
Is there a limited number? No, is there a limited number to the cycles? Do you have a specific number?
Specific number.
Yeah, for the number of cycles.
Machine cycle is according to the oscillator period. So machine number is definite.
Okay.
Definite. But sometimes if we use the assembly language, we can get the accurate delay. But if we use C language make a program, maybe it's different. We can get the time we expect. So when we make a program with assembly language, we can get the accurate the delay. But if we use C language, we cannot get the actually delay time. Find the size of the delay in the following language. If the characteristic of frequency is here is according to the last slide, we can get the machine cycle is 1.085 US. So we just get the how much machine cycle the instruction spent, so we can get the time we delay. Here. Here is the time delay. Delay. Move is one machine cycle. Here DJ and Z is two machine cycle. So the R3 equal to 200. So this loop executes 200 times. So we can get here is execute 200. So two multiply 200 and add. This is one cycle machine cycle. This is two machine cycle. So add one and add two, so we can get the all the machine cycle and multiply the period. So we get the delay time. find the size of the delay in the following program if the alternative frequency is 11.0592 million hertz. Here is the loop. Here is a loop. Loop R3 is 250. So the loop executing 250 times. Here is 1, 1, 1, 1, 1, 1, 2, 3, 4, 4 add 2. So add 2. So is the machine cycle, the loop. Multiply 250 and multiply the one machine cycle. So we can get the delay time for the loop. But before the loop, we have execute the two factors can affect the accuracy of the delay. Crystal frequency. The duration of the clock period of the machine cycle is a function of this crystal frequency. 8041 design. The original machine cycle duration was set at 12 o'clock, but recently the new type of 8041 we can maybe one clock period is one machine cycle. The 89 C51 8 mil 12 o'clock for the one machine cycle 12, but this microcontroller has 6 clock. This has one clock. So if we use the traditional 8041, we can get 12 clock for one machine cycle. But the new type of 8041 maybe is different. So when you use the microcontroller, you need to check for the machine cycle. This is an example for different microcontroller. You can calculate machine cycle. This is simple, so I don't introduce. Okay. Different type of 8041 has a different machine cycle. So the instruction maybe execute with different machine cycle. In the 8041, the move R3, .55 execute within one machine cycle, but on the DSC 89C4, this instruction will spend 2 machine cycle. So you needn't to remember how much machine cycle the instruction spent. If you want to know, you need to check the reference instruction book. Okay. I finished introduce the jump, loop, and the core. Core. We can have a break. Okay, you can have a rest. I introduce the new point about I/O port programming. I/O port, which means we can continue communicate with the outside device by the I/O port. This is 8041. 8041 has I/O port P1, P3, P0, P2. After we finish this class, you may know how to use the P0 to P3. The four bit I/O ports P0, P1, P2, and P3 each use 8 pins, which means every port has 8 bytes. All the ports upon reset are configured as input, ready to be used as input port. When you power on the microcontroller, the ports configured as input port. When the first 0 is read to the port, it becomes an output. You need to remember, when the first 0 is written to the port, it becomes an output. To reconfigure it as an input, 1 must be sent to the port, which means before you use the port as an input, you need to write one to the port. To use any of these ports as an input port, it must be programmed. You need when you use that as a import or output, you need to do something before you use it. It can be used for input or output. Each pin must be connected external to an 10K ohm per up resistor. This you need to be careful. When you use P0, you need a pull up resistor, but P1, P2, and P3 didn't. This is important. This is due to the fact that P0 is an open drain. Open drain means there is no resistor on the pin. There is no resistor on the pin. Open drain is a term used for most chips in the same way that open connect is used for TDL chip. Open connector, which means connector pin, there is no resistor on the connector pin. if you use P0, you need to add the resistance like this and give the power. So it's the standard use. The following code will continuously send out to port 0 the alternating value of 55H and AAH Move A equal to 55H. Move A to P0. Delay. Move AA to P0. Delay back. In order to make port 0 an input, the port must be programmed by writing one to all the bits. Port 0 is configured as first as an input. By writing ones to it, and then data is received from that port and sent to P1. We can analyze this program. A is equal to FF, and move A to P0, which means port become an input and output. Get the date from port 0. Move A P0 to A. Move A to P1. Back. This is transfer the data from P0 to P1 with A. But before you use the port, you need maybe you need to write 1 or 0 to the port. Configure the port. Port 0 also designated as AD0 to AD7, and now it be used for both address and date. When connecting an 8041 or 31 to external memory, port 0 provides both address and date. Here you need to remember, when we use port 0 as address, port 0's no 8 bit. 8041 has 16-bit address, so the higher 8 bit output from P2, So when port 0 used as address, port 0 and port 2 use it together. Port 1 can use as an input or output. In contrast to port 0, the port does not need any pull-up resistor. Does not need any pull-up resistor, since it already has pull-up resistor internally. Upon reset, port 1 is configured as an input port. The following code will continue sent out to port 0, alternating the value of 55H and AAH. This is an example of you write A to port 1, write A to port 1. To make port 1 an input port, it must be programmed as such by writing 1 to all its bits. Input port, writing 1. Port 1 is configured as input port by writing 1 to each. Then data is received from that port and saved in R7 and R5. Here is write 1 to port 1. Then you can read your data from port 1. Port 2 can be used as input or output, just like port P1 or P2. Just like P1, port 2 does not need any pull-up resistor. Does not need resistor. It already has pull-up resistor internally. Upon reset, port 1 is configured as an input port. It's the same as other port. It's the same with other port. Is the same to the other port. To make port 2 an input port, it must be programmed as such by writing 1 to all its bits. In many 8041 based system, P2 is used as a simple I/O. Used as simple I/O. In 8031 based system, port 2 must be used along with P0 to provide the 16-bit address for the internal memory. Port 2 is also designated as A8 to A15, indicating its during function. Port 0 provides A0 to A7, which means that if you want to use 16-bit address, you need to use port 0 and port 2 together. Port 2 is address A0 to A7. Port 2 is the address is from H8 to H15. Port 3. Port 3 can be used as input or output. Port 3 does not need any pull-up resistor. Port 3 is configured as an input port upon reset. This is not the way it is most commonly used, because we can use port 1 separately every bit. Port 1 has the additional function of providing some extremely important signal. Here are port 3 has use it together as a port, or every bit has its function. Every bit has its function. Port here are P3.0 and P3.1 use as serial communication. Port 3.2 and 3 use as eternal interrupts. And here are point 4 and point 5 use as timer. Point 6 and point 7 use as write and read signal. So when you use the port 0, port 1, port 2 and port 3, port 1 and port 0 and port 2 sometimes used together. Port 3 has additional function for every bit. So you need to remember it. Write a program for this microcontroller. Toggle all the bits of P0, P1, and P2 every quarter of a second. Here is the program. This all the instruction I have introduced. So here is a task for everyone. After I give you the PPT, and you need this program Protos, and you run this program on the Protos, and record the screen and send it to me. Understand what I see? Assignment, a task for you. You install this program on your computer, and run the program on the PPT, and recording the screen as a movie. As a movie. Video. Recording the screen become a video, and send it to me. Okay? Which means I need you to exercise the language. Sometimes just I said something here. You don't know nothing. You know nothing. Am I right? So if you want to learn the microcontroller good, or you need exercise by yourself. Yeah. Here is a program you can exercise. Exercise.
Yes, we can copy this one.
When we finish, you can copy the
This
PPT.
program.
Yeah.
Just paste to there and then try. This happens or not.
You have the code.
Yeah.
You just copy and
Yes.
paste into the Pro Tools.
Photos. Yeah.
Yeah, and run. Yeah. But when you run your program, you need to check the register. You need to check the register, just like here. Here is the register. You need to check.
All registered.
When you run the program line by line, step over source line, just run line by line. So you recording the process and send me the video. Yeah.
তো মেঝের মধ্যে ঢুকতেছে না, এখন পড়াশোনা করতে হবে, উপায় নেই। বুঝছো, অনেক সময় নষ্ট করছে, আমিও বুঝছি, সবাই বুঝছি। এখন বাধ্য পড়াশোনা করতে হবে। মেকানিক্যাল ইঞ্জিনিয়ার তুই ইঞ্জিনিয়ার।
What's wrong?
Nothing.
You talk about the class?
Business.
Sometimes we need to access only 1 or 2 bits of the port, so we can use just like P1.2, P1.2, complement P1.2, CPL. Delay, let's jump. If you want to access 1 bit, just use P x point x, just like this. Here is an example. Run the following program, creates a square wave of 50% duty cycle on bit 0 port 1. This is your task. You run this program. Okay. Here is some instruction that are used for signal bit operation. This is set bit equal to 1. CLR set bit to 0. CPL not bit. JBC is according to the bit state to jump. According to the bit status to jump. This is some instruction about the bit operation. The JMB and the JB instruction are widely used signal bit operation. They allow you to monitor a bit and make a decision depend on whether it's 0 or 1. These two instructions can be used for any bit of I/O ports and I/O ports. Port 3 is typically not used for any I/O, either single bit or byte-wise. Single byte. Often we use port 3 for the additional function, not for the I/O port, not for the I/O port. Here is the instruction for reading and an input port. Reading and input port. Move, move, JMB, JMB, JB, move. Here is the example. Sorry, I changed the PPT side. The arrangement is changing. Here is the program to perform the following. Keep monitoring the P.2 bits until it becomes higher. When P1.2 becomes high, write the value 45H to 0. Send high to low pulse to P.3. So we analyze this program. Set B P.2, which means P.2 is equal to 1. Make P.2 an input. Make an input. Move A, pound 45H. A is equal to 45H. This get out when P 1.2 is equal to 1. JMB not 1 jump, not 1 jump, which means wait here until P1.2 is equal to 1. The function of this line is wait here for the P1.2 is equal to 1. After P1.2 is equal to 1, just execute this. Move A to P0. Move A to P0. A is 45H. This means A is equal to 45H. P0 is 45H. Then set P2.3, which means P2.3 is equal to 1. Here is clear. Here is 1. Here is 0. Here is 1. Here is 0.
You said P2.3 is equal to 1. How?
P2 point.
Yeah, P2.3.
P2.3.
Yeah, is equal to 1. How? How is it equal to 1?
How is it equal to 1?
Yeah.
Oh. Sorry. here this instruction set B is make the P of 2.3 become 1, Yeah. CLR is make the this bit becomes 0, Yeah. Maybe you not see the set B, just see the set. This is another example. You can test this example for yourself. Okay. Here is another example. In reading a port, some instructions read the status of port pins. Others read the status of the internal port latch. Therefore, when reading port, there are two possibilities. Read the state of the pin input pin, or read the internal latch of output port. Confusion between them is a major source of error in 8041 programming, especially where external hardware is concerned. Sometimes we need usage with the outside hardware. Some instruction read the contents of an internal port latch instead of reading the state of an external pin. Some instruction read the latch. Some read the external pin. For example, look at the ANLP1A instruction, and the sequence of action is executed as follows. ANL is AND for AND code for the P1 and A. It reads the internal latch of the port and brings that the data into the CPU. First, second, this date is ANDed with the content of register A. Thirdly, the result is rewritten back to the port latch. The port pin data is changed and now has the same value as the port latch. This is only one instruction. Actually, the microcontroller executes as follow four steps. Read, modify, and write. The instruction reads the port latch, normally read a value, perform an operation, then rewrite it back to the port latch. Instruction, reading a latch. Read, modify, and write. This is this all the instruction work. Read, modify, and write. The port in 8041 can be accessed by the read, modify, write technique. This feature saves many lines of code by combining in a single instruction, all three actions. Read the port, modify it, and write into the port. Yeah, this instruction read, modify, and write. Okay, this PPT is for the I/O port. So I give you the task. You need to finish it as soon as possible. Okay. Anyone has a USB disk, or just I use my USB cord to your laptop. Yeah. After when we finish install this program, we pick the 8041 from here. Yeah. Just use 80LAN C41. Use 80LAN C51. Double click. Then the 8089C51 is added here. So click and put here. Yeah. I already put one. Delete. After you put the microcontroller, you double click here.
Yeah.
Edit firmware. So you can enter the program, edit display interface. Here is write your code here. You can copy the code from the PPT here, or you just type by yourself. After you be careful, don't watch anywhere else. Just put your code here. So after that, build project. If here show the project is successful, rebuild. Build. If you have already built once, you can use rebuild. Compiled successful. Okay, is successful. If show error, you can check your program. Show some error, you can check your program. Okay. After compiled successful, debug. Start. You can separate the screen to two parts. The top part, higher part is for your source code. The lower part is for your register. If you cannot see this window, just here. Yeah, here. Click register. Or the SFR memory. Okay. Okay. Run step over source line, which means run your code line by line, line by line. So you can click here or press F10. Press F10. Yeah. Here it's a right triangle. Right triangle means the current code is here. Current code is here. You can see ACC is 0. Here I can next move to the next. ACC is 0 because this is move 0 to A. A is 0. A is 0. Next, move R2. Move 10 to R2. So you can check R2. A is 10. A is 10. AH is equal to 10. So, yeah. So you can execute next. Next, add A and 3. A is 0. So add A and 3 is 3. You can see ACC is 3. Yeah. ACC is 3. Yeah. Sorry, right? R2 discriminated by 1. So you can see out step R2 is here. R2 is here. Right? R2 is here. Here R2 is equal to 10. After this line this code is executed, R2 become 10, but become 9. Yeah. Okay, you can try again. Step over. Yeah. Add A and 3. A is 3. Add 3 become 6. Yeah. So you can show your program like this. Yeah. 就像这样一样。我说的中文能听懂吗？就像这样一样 ，just like this. Yeah. You need a screen recording all this process. All this process, and I know you do your homework. Yeah. Okay. Anything I need to explain? Okay, so much for today. We can continue next week. So which is the wrong. R2 I type wrong as H. Okay, you can see it's build. Error 1. You can see error 1. Here is error 1. You can see symbol is not defined. 36 9. 36 is here. 36 is here. Yeah. R8 is not existed. So you need to change this RH to R2. So succeed. Build.
project
Yeah, successful.
successful.
Yeah. When there is some error in your program, this software will show where is your error is. Where is your error is.
That's more complicated.
Okay.
Okay.
Any problem? Maybe you test your program. You have many problem. We can discuss next time.
Next
Okay.
time, yes.
Yeah.
When you want to work something, then we can face this problem.
Yeah, yeah. If you some error happens, you can
Yes.
try to solve the problem.
Yes, yes. And then
But
not
if you
possible,
cannot solve the, we can discuss together. Okay.
not-
Yeah.
not much.
Okay. So much for today.
Not much.
Yes.